We think of eating as an experience, driven by culture, cravings, or hunger. However, from a biological perspective, a slice of pizza or a bowl of rice are just delivery vehicles for chemical energy and structural building blocks. The modern food environment often clashes with this biological system. We are surrounded by empty calories, foods like sugary drinks and fried snacks that pack massive amounts of energy while lacking the actual nutrients required to maintain our cells. Industrial trans fats are a prime example. By artificially hydrogenating oils to make them solid at room temperature, food manufacturers create a chemically altered fat that human cells are not designed to process safely, which elevates the risk of cardiovascular disease. To figure out what we actually need to put on our plates, we have to look past the dining room table. We need to track our food into the microscopic chemical processing plant of the human body. Every bite we take acts as a precise chemical transaction. In our current environment, much of what we consume provides our biological hardware with corrupted code. The processing starts the second food hits your mouth. Saliva begins the breakdown while you chew, and as the food travels through the esophagus and into the stomach, it is churned from macroscopic bites into a microscopic slurry. This is where enzymes take over. Think of enzymes as biological scissors, constantly snipping the chemical bonds of massive food structures. They reduce these structures into the body's usable currency, the 7 essential nutrient classes, from carbohydrates down to vitamins and minerals. This process goes beyond simple dissolution. Our digestive system operates as a highly coordinated disassembly line, preparing raw materials for cellular uptake. We categorize these raw materials by how much of them we need. Macronutrients are the heavy lifters, required in large doses for physical structure and energy. This chart shows macronutrient energy density. Proteins and carbohydrates both provide 4 calories per gram, but lipids, our long-term storage, pack 9. These macros rely on 0-calorie micronutrients, vitamins, minerals, water, and fiber, which act as vital biological lubricants to keep the machinery running. Biological survival requires a precise balance between the heavy bulk fuel of macronutrients and the trace 0-calorie regulatory tools necessary to process them. Once that bulk fuel is broken down, we track it deep into our cells. Carbohydrates circulate in the bloodstream as a stable molecule called glucose. The energy in that glucose is actually stored solar energy. Plants capture sunlight and lock that energy inside the chemical bonds of glucose through photosynthesis. Human cells cannot use glucose directly to flex a muscle or fire a neuron. They require a highly specific energy currency called ATP, or adenosine triphosphate. Through a process called cellular respiration, our cells shatter the chemical bonds of glucose, releasing that stored solar energy and using it to manufacture ATP. That ATP then powers every nerve impulse and muscle contraction in the body. Beyond the food on the plate, every thought and movement originates from the release of captured solar energy. Maintaining this system requires a constant, high-quality resupply. If we zoom back out to the scale of the whole human body, we can see the physical results of an unbalanced molecular ledger. It comes down to a strict mathematical ledger. When we consume more chemical energy than our cells actively convert into ATP, the surplus remains in the system. The body is forced to store that excess material in lipid cells as body fat. Over time, this expanding storage creates severe systemic strain. Excess fat distribution alters hormone levels, disrupts metabolism, and triggers widespread inflammation. Fatty deposits build up in the arteries, driving up blood pressure and significantly increasing the risk of mechanical failures, like a heart attack or a stroke. These chronic diet-related diseases are the large-scale physical manifestation of a long-term microscopic energy imbalance. The AMDR sets a baseline to optimize energy: 45 to 65% carbohydrates, 20 to 30% fats, and 10 to 35% protein. Harvard's Healthy Eating Plate translates this to the table: half the plate vegetables and fruits, a quarter whole grains, and a quarter proteins. This biological math holds true regardless of dietary philosophy. Whether a person eats an omnivorous diet or follows a plant-based vegan diet, the cellular requirement for these specific macros and micros remains identical, only the delivery vehicle changes. Ultimately, nutritional choices serve a specific purpose, providing our complex biological machinery with the exact chemical code it needs to perform, function, and thrive.